So just when you thought it was safe to deploy Wi-Fi 6, hot on its heel is the next evolution, Wi-Fi 6E. So in this presentation, I'm going to be taking a look at what Wi-Fi 6E is at a high level, and then looking at some of the challenges that that's going to potentially create within your networks. There is obviously a consideration as well whether you actually need to Wi-Fi 6E, the next evolution. It is about capacity, about additional spectrum, so we'll kind of look at that. So it's not necessarily something that you need to stop right now and think, oh, I'm not going to put in Wi-Fi now because there's this next evolution coming along. It is some way out. We're starting to see products at the end of this year potentially. Potentially seeing clients, but just like with any other evolution of Wi-Fi, it takes a few years to actually sort of get embedded and become the majority of devices and networking components. Really the main part around this is then sort of looking at how your wired network will actually cope with this next evolution of Wi-Fi as well. So just by a quick way of introduction to myself, so I work in the pre-sales team in the UK, so there's a team of 5 pre-sales engineers. So we're helping the channel partners, all aspects related to the pre-sales cycle, so whether that's helping with information about products, configurations, optimizations, bills of materials, site surveys, bespoke training, things like that. That's effectively what we're here to do, help the channel partners with, and obviously that kind of flows down to their customers as well, in terms that if the channel partner's well supported, then their customers are also well supported as well. The actual part of the business unit I work with, so as you can see from me, the long history, I've been at Ruckus for about 14 years. I started when it was a very small company and went through IPO, then we were acquired by Blockade, and that was acquired by Aris, and that was acquired by CommScope. So we sit as a business unit within CommScope, so we're known as the Venue and Campus Networks business unit, and that consists of Ruckus plus some other parts of the business as well. But effectively, enterprise networks is what we're focusing on. So whether that's enterprise networks into market verticals like hospitality, education, healthcare, into retail, also includes places like public venues, stadiums, and so on as well. So pretty broad in terms of the markets that we actually serve within this business unit. And just about myself, I mean, one of the things that I've enjoyed myself in terms of this role, the thing that I've actually enjoyed is that pre-COVID was actually getting out and about and seeing places that you wouldn't necessarily kind of see as a normal person. So whether it's the inside workings of a hotel or a stadium, where it's going into the changing rooms at the Emirates stadiums or the manager's office, through to number 10 Downing Street. It's been an interesting experience in getting out and seeing places that most people don't actually get to see. So that's kind of what I enjoy, as part of the job and role, and also of course, have a lot of pride in the Ruckus products and how they help, our customers to implement networks, that are reliable and scalable, and help to run their businesses and communications on top of them. In terms of what Ruckus is about, we are there, or we are here. Sorry, Carl, I just want to check, is this the bar at the top is showing in mine? I can't seem to minimize that.
Nope, I've got full screen on mine.
Green. Okay, just want to check, see whether it's actually shading any of the display. I don't know why it normally just disappears, but it's not doing so. So in terms of what Ruckus Networks is doing in this part of the business unit, is all about connecting users and their devices to the applications and services that they need access to. So whether that's communication services such as email, whether it's it's web servers across the internet, whether it's financial or other types of services, HR services, local services within the customer's own data centers and so on. It's all about that connectivity. And today, we're seeing a variety of different devices, whether they're wired or wireless devices. There may be traditional things from, VoIP phones to laptops, to other computing devices, tablets, smartphones, printers, wireless cameras for security. And then we start to see obviously a lot more as well proliferation of IoT devices connecting to the network, typically wirelessly connecting using Zigbee protocol or BLE, for example, and providing services for IoT as well. So different services, whether that's environmental services, environmental monitoring, maybe security related, physical access security, maybe related to building management or whatever. So, we also have a good solution around the IoT side of things as well. But it is about connecting, the devices to the applications and services that they actually use. So looking at the agenda at a high level, so we're going to first of all just start with a review of Wi-Fi, Wi-Fi 6 that is. So that is the current shipping technology. So customers are still deploying Wi-Fi 5, which is 802.11ac standards based or Wave 2 based. Wi-Fi 6 has been around for a while now. Originally, the sort of draft specification was out in late 2018. That's when we had our first Wi-Fi 6 access point. And that's continued to gain ground, but people still are deploying Wi-Fi 5 networks. They are a reliable technology, and for a lot of customers, they still satisfy the need. And as we start to talk about Wi-Fi 6E, the next evolution, Wi-Fi 5 or Wi-Fi 6 itself can still fulfill the needs of many of our customers. So it doesn't mean that you need to hold back, as I mentioned at the start, in terms of your deployments of Wi-Fi, thinking that there's another, a greater thing around the corner. In most cases, the existing technologies will meet the needs of the majority of customers. But we're going to take a look at Wi-Fi 6E, what the differences are there, how it may potentially benefit your network. Then we're going to look at the network considerations of Wi-Fi 6E. Obviously, more capacity, more performance is going to have an impact potentially on your existing networks from a wired perspective, power perspective, more power hungry APs, and also on your cabling infrastructure. And then we're going to take a look, lastly, at how our ICX switches, so multi-gig switches, can help to complement those Wi-Fi 6E deployments. So what do they actually bring to this new evolution of Wi-Fi in terms of high performance and capacity? In terms of just reviewing Wi-Fi performance over the years, it has come a long way. And whilst with 11AC, which is known as Wi-Fi 5 today, it was touted as multi-gig Wi-Fi, and certainly with the right clients and the right access points and infrastructure, you could certainly exceed 1 gigabit of physical throughput. And here we're looking at the PHY data rates here. So when we're looking at sort of 9.6 gigabits per second for 11AX or Wi-Fi 6, we're kind of looking at the PHY throughput. So the actual throughput is typically going to be 50 or 60% of that best case. But you see the speeds have increased dramatically. Wave 2 of 11AC did bring potential of breaking the physical 1 gigabit per second barrier on your wired network and infrastructure. But 11AX or Wi-Fi 6, certainly does take that to the next level in terms of its capacity, and Wi-Fi 6E will take that even further. So Wi-Fi performance has really improved over the years, and that is starting to show that it's kind of outstripping in some cases some of the developments in terms of the wired networking world. Just looking at Wi-Fi 6 itself and what was certified by, or what's on the certification program for the Wi-Fi Alliance. So these are the guys that actually do all the certifications. They take the standards and decide what features and functions and levels of security should be included in each Wi-Fi release. So some of these are already familiar. So their technologies that are around in the Wi-Fi 5 world and previous versions of Wi-Fi as well. They've continued to kind of grow and adapt as well. But these are really the features that are being certified, or key features certified in Wi-Fi 6 itself. So we've got downlink multi-user MIMO. So this is where the AP is actually able to communicate with several devices downlink at the same time. So that's a pretty useful feature in terms of improving the capacity of your network. So if you're streaming video to a bunch of devices in a classroom, for example, if you can stream to multiple devices at the same time, then obviously that's going to benefit in terms of servicing the clients much more efficiently than just doing it on a one-to-one basis. Something new that's been added to Wi-Fi 6 was a new type of modulation known as OFDMA. So this actually comes from the cellular world. I mean, there's other radio technologies, communication technologies that use it as well, but predominantly the one we're familiar with is, but it's actually used by like LTE networks, for example. And this works slightly differently to the traditional stream-based multi-user MIMO that we see on the left there. What this actually does is to take the channel and split it up into what's known as resource units, and each client is allocated a resource unit and communicates over that resource unit. So it's effectively, rather than using multiple streams, it's splitting the channel width up into kind of like sub channels effectively, and that gives you the ability to actually do multi-user MIMO to lots of clients, albeit at potentially a slightly lower bandwidth than what you get with traditional streams-based multi-user MIMO. So it is a more efficient way of actually utilizing the spectrum, especially when you want to communicate with multiple devices, both in the downlink and the uplink direction. Transmit beamforming is something that's been around for a long time, so that's just part of a standard certification program now. As is also 160 megahertz channel width. So some versions or some previous versions obviously had narrower channel widths, and since Wi-Fi 6, 160 megahertz wide channels have been part of the certification program. We have target wait time, which is a negotiation between the client and the AP in terms of a scheduled sort of sleep and awake pattern. So the AP knows when there's data to be sent or received from the client. So it makes that a lot more orderly and helps to preserve the device's battery power. So that's obviously important for things like your smartphones connected to Wi-Fi. So more orderly controls of when the device wakes and sleeps helps to improve the battery life of those devices. And it also helps to provide a bit more order overall in terms of communication cycles between clients on the Wi-Fi network, which again helps to improve the capacity of the Wi-Fi network rather than it being quite so as random as it was in previous versions. BSS coloring is a useful feature when you've got high density deployment of APs where you've got overlapping spectrum. So if you have, for example, two APs on the same channel that are sort of in adjacent rooms, for example, are overlapping, but the actual BSSs can have like a tag added to them, what we call a color. So that means that whilst they're overlapping in terms of the same spectrum, in previous versions of Wi-Fi, one or the other would actually have to back off its communications. With Wi-Fi 6, they can continue to communicate, and that BSS coloring is used to differentiate which access point they're actually communicating with. So again, it improves the efficiency and the coexistence in the high density deployments. Efficiently support up to 8 spatial streams. So in previous versions of Wi-Fi, so like Wi-Fi 5, for example, typically you'd see no more than 4 spatial streams. Do support up to 8 spatial streams. So that's can be a pretty significant increase in terms of the performance of the access points. And when you're supporting things like downlink multi-user MIMO, using those spatial streams, that can be a significant improvement. And we've also gone from 256-bit to 1024-bit QAM. So this is how many symbols can actually be used to represent the data when it's being transmitted. So that's a pretty significant increase in terms, you may be getting 20 to 30% more performance effectively of using 1024-bit QAM rather than 256-bit QAM. The only thing with this is that it does require a strong signal. So the client needs to be fairly close to the access point and needs to be a pretty clean RF environment. So these are the key features of Wi-Fi 6. So what is Wi-Fi 6E? So the E just stands simply for extended spectrum. So the regulators around the world have been opening up new bits of spectrum in the 6 gigahertz band. So as you see, it starts just under the 6 gigahertz band, but it's known as 6 gigahertz. And so what we're actually doing is open up this additional spectrum and allowing that to be used. So in the UK here, for example, and across Europe, it's pretty well harmonized. So we're actually getting 500 megahertz of additional spectrum. And that equates to around about 2420 megahertz channels. So it's kind of roughly the same channel plan as what you're getting 5 gigahertz currently. So as you can see here, this on the left is the channels organized into the 6 gigahertz spectrum. And if you look just as comparison, UK, for example, in 5 gigahertz, you get much the same. So it's just slightly different in terms of the start and end, the actual width of that spectrum, but it's pretty well the same number of channels. So as you can see, this is really kind of taking it to the next level in terms of capacity. It's not really, Wi-Fi 6E isn't about performance as such. There's not really anything in it, but it's faster, like QAM 204/8-bit or something like that, or 20 spatial streams. It is about just the the additional spectrum. In the US, as you can see, it's it's a completely different story. They get more than twice the spectrum that we get in the UK. So that's that's really kind of significant for the US market in terms of Wi-Fi. That said, it does come with some downsides. We're not really too affected by it here in the UK, but there are already in the spectrum. It's not freely available. There are already other things allocated to the spectrum. So there are things like satellite data uplinks in there, and there are broadcast applications that use parts of the spectrum. So that's the same for the the part that's being used in the UK and Europe, as well as in the US. So it's not completely brand new clean spectrum. There are other systems using parts of the spectrum. In the UK, for example, it's not really going to affect us too much. How they're dealing with this is that they're going to have standard power modes, low power modes, and very low power modes. So typically in the UK, we'll be supporting very low power and low power modes, not standard power mode. Once you start to support standard power mode and want to use that outdoors, for example, there are sort of considerations about what it may be interfering with. So there's effectively, for example, in the US, when using standard power outdoors, there's actually like a registration system that you actually have to go through. So it's not a license, but it's a registration system where people or companies already using, or whether it's sort of commercial companies or government bodies, whatever it may be, already using part of that spectrum, and they all sign up to put their details into this database so that you can make sure that you're not actually going to interfere with their spectrum in a deployment. So it's a lot of spectrum. Has a little bit of challenges, but it's for us here in the UK and Europe, it's not too much of an issue, and especially indoors, it's not really an issue using just the low power and very low power modes. So what are the key features and benefits of Wi-Fi 6E? So first of all, we know that it's extended spectrum, so that 500 megahertz in the 6 gigahertz band. And the other thing is, aside from what I've just said, there are very few sources of interference. When you've got things like satellite uplinks, downlinks, communications, they're not really going to affect, because they are pretty directional in terms of their sort of spread. So they're not really going to have much impact. It's not like radar in 5 gigahertz, but can have a pretty wide breadth of where it will interfere, for example, in outdoor deployments. There's not really any of that going on. So from a Wi-Fi perspective, it is a pretty clean spectrum. So there's a lot less sources of interference, especially compared to something like 2.4 gigahertz. So what does this provide? So, that ability to actually, use that additional spectrum on top of the other two bands, the 2.4 and the 5 gig with Wi-Fi 6, does mean that true gigabit speeds are possible. So certainly well in excess of that 1 gigabit per second speed, going up to 2, 3, 4 gigabits potentially or more of actual data throughput from from an AP across the Wi-Fi network is certainly going to be something possible in the future. This less interference also means that typically, with high performance, less interference, you're going to have lower latency as well. So that's really good for real-time applications, video streaming, voice, that sort of stuff as well. And it's going to significantly improve the capacity. So where, the main benefit we see of Wi-Fi 6E is in places like, conferencing and public venues, stadiums, where you're going to have high densities of users. And that's really going to be the biggest benefit. So, in a lot of other areas, as I've mentioned, it's not necessarily going to bring a huge amount of benefit. So in education, it may help a bit, but pretty well in most, in most schools, having 5 gigahertz is more than sufficient. So it is, typically going to be aimed at those really high capacity venues with high client and AP densities, which is where it's going to come into its own. And to your businesses, what it means to you, to your customers, what it means for you is that if you've got big blocks of data that you need to move around, then you can move that data around much faster, obviously with multi-gig speeds. It's going to improve reliability with less interference. If the applications, real-time applications, will be more responsive, and you're going to be able to connect a lot more devices as well per AP. So that helps to give you an improved ROI by being able to significantly increase the number of clients that you have connected per AP as well. So that's fewer APs to be deployed, fewer cable drops, less power consumed, and so on overall. In terms of Ruckus and where we are in the roadmap, so this is the plan of intent. So these are not committed products or specific shipping dates, but we're looking at bringing out our first high-end product, which is tri-band. So this is not software-defined radios or anything like some of our customers have. It's a fixed 2.45 and 6 gigahertz radio in here. So you can see it's 4 streams on all of those radios, so pretty powerful beastie there. And that's going to be due to be released in Q4 of this year. Then start of next year, we're looking at doing a premium mid-range AP, tri-band AP. So that'll be 2 streams on each of the radios there. Don't really have any dates, any more granular than first half of next year. We're starting to see, we expect to see sort of client devices coming out towards the middle sort of Q3 of this year. So it's a little way off, but it's going to really be sort of, I think for the masses, it's not going to be until 2022 that we start to see any kind of serious uptake in deployments, especially outside of very high density venues like stadiums and conferencing centres. Taking a look at the network considerations for deploying Wi-Fi 6E. So there are really 3 main areas that need to consider. There's the performance aspect, performance bottlenecks within the existing network. There's power over Ethernet capacity. So, how much power can existing switches provide to power these tri-radio APs, but also have other radios in them. So they have, the IoT radios in them as well. Multi-gig ports. So it's performance, it's power for those. And also a little bit of consideration about the existing cabling infrastructure as well. The cabling infrastructure is both for structured cabling and also potential fiber links as well, between buildings, as well as internet uplinks as well. So Wi-Fi 6E is going to shift the performance bottleneck. We've already seen that kind of happening already today to a degree with Wi-Fi 5 and Wi-Fi 6 starting to be deployed there. So the old bottleneck used to be the Wi-Fi network itself. Wi-Fi 5 with Wave 2 APs, if you've got a high-spec 4-stream AP, potentially you could break the 1 gig actual throughput barrier, but it was pretty unlikely in most cases. With Wi-Fi 6, you could certainly break the 1 gig barrier. And with Wi-Fi 6E, you go another magnitude past that potentially. So definitely that sort of old bottleneck, which used to be the Wi-Fi network, is shifting. So in the old days, less than 1 gig of actual throughput. 1 gig connectivity to your access network was fine, and typically 10 gig or 40 gig sometimes, but typically it was 10 gig uplinks to the aggregation of a core network were more than sufficient. Now breaking through that 1 gig barrier of actual data traffic, more clients connecting, higher throughput applications and everything else, that bottleneck is definitely shifting to the wired network and other places in your network. So 1 gig is no longer going to be sufficient for connecting your APs to your switches in a lot of cases. You're going to need to look at 2.5 and 5 gig connectivity, or multi-gig as it's commonly known. And then obviously your backbone also needs to shift up a gear. So rather than being just 10 gig potentially, you need to potentially be looking at 40 gig or 100 gig connections into the aggregation of a core network. And it's not just about access points as well. I mean, in terms of other devices, there are other devices that are making use of multi-gig capabilities. So pushing past that 1 gigabit barrier. So whilst APs is a big driver for this, there are other devices as well. So whether it's related to security products, whether it's related to some specific applications, that there is a need to go past that 1 gigabit barrier within the network itself. So see more applications coming up from that for high performance connectivity. So I mentioned the power. You can see that with legacy Wi-Fi, the power draw used to be not particularly huge. It was up to PoE plus, or 30 watts maximum being supplied out the switches. With Wi-Fi 6, we've seen an increase there potentially, and especially adding IoT to go into BT. And in the future, you're going to be sitting more, so it's sort of sitting at the AT and above level. So AT and BT power specifications at least for your Wi-Fi 6 APs with 3 radios. And if you include the IoT in there as well, potentially, as more powerful APs come along, they may even require higher power than that as well. So definitely, the switch infrastructure needs to be able to support higher than AT power if you're looking at going forward to Wi-Fi 6E. And of course, it's not, as I mentioned, it's not just in terms of, APs for throughput, but also in terms of power as well. You see a lot more computing devices as well becoming more, more popular, which are powered over Ethernet, displays and things like that, as well as, obviously cameras and other devices that are actually being powered over Ethernet, lighting within buildings and so on. So, there are, outside of, the Wi-Fi network and Wi-Fi 6E, there are a lot more demands to be able to provide higher power to devices connected to your network. And this again just is indicating that, access points make up a large part of what's pushing, the demands on PoE up, but there are a lot of other devices as well that are helping to sort of drive that trend, as well as increasing power usage via PoE switches. Just taking a little bit of a look at the structured cabling side of things. I'm not really going to cover fiber in this, but obviously, your fiber and your internet speeds are also a consideration if you're looking at Wi-Fi 6E. But this is really just based around the structured cabling deployment. So when we talk about multi-gig, so this is this alien limited signal to noise ratio is a calculation, but actually works out the sort of a risk of running certain speeds over certain lengths of data cables. And so what we kind of start here, we'd always be recommending that you should be running category 6A, because all speeds are assured across category 6A. However, if you've still got legacy category 5E or category 6 cable deployed, some of these high multi-gig speeds will still work up to specific distances. So on the left here in each of these boxes, you can see what sort of distance we've actually got this, this risk level being assessed at. So, up to 75 meters even potentially. You can still run some multi-gig, but the further the higher or the longer the distance of your cabling, the more risk there is. And something else that's going to exacerbate that issue as well is things like the size of cable bundles and heat as well, because that will affect performance. And if you're doing PoE and you are driving higher PoE budgets across those cables, they are obviously going to get that little bit warmer as well. So higher temperatures affect the performance of the cable. So it's not a kind of a black and white picture of this saying that it's definitely going to be okay, to run 2.5 gig at 75 meters over category 6. In your particular case, it might only work reliably at 50 meters or 55 meters, but this just gives you a bit of an indication. And when we are looking at true multi-gig and running access points about up to 100 meters away from the switch, category 5E and category 6 don't really cut it. You do need to be using cat 6A everywhere. So definitely, if you're looking at upgrading your infrastructure, whether that's Wi-Fi 6 or Wi-Fi 6E, you're looking at potentially pushing multi-gig of throughput from access points or other devices, then you need to look at that cabling infrastructure and make sure it's actually going to provide the performance that's required and be reliable. Let's take a look at our ICX multi-gig switches and how they may be able to help out with these types of deployments, and say not just for Wi-Fi 6E specifically, but for other devices that you're connecting as well. So we've got our Wi-Fi 6 APs. We'll soon have our Wi-Fi 6E APs. We've got IoT as well as part of the solution I've mentioned. It's about providing as we're going through Wi-Fi 6 onwards, it's about high throughput and low latency, driving bigger data transfers, more real-time applications. But it's also about wanting to have that single pane of glass. So not that you're just managing your Wi-Fi network, but you're also managing your switch network. So this is really where our ICX switches come into play. The ability to manage those ICX switches through the same network control method. Working better together there makes it much easier to manage your Wi-Fi and your wired infrastructure. And at a high level from our ICX switches, we've got multi-gig port options. We've got very high PoE budgets as well. So across the switches, we have some switches that are just providing AT power, then we've got switches that provide the full range of BT and other options like UPoE as well. Great performance as well, so non-blocking architectures. And in terms of deployment as well, we don't have any chassis. We very much see the sort of chassis-based solutions of the dinosaurs of the networking world. in terms of they're pretty inflexible. They're very expensive. So our mantra is about scale out. So just having stackable switches that you can add switches as and where you need them and provide the capacities for that particular area. So it gives you a lot more agility and is also a lot more cost effective than putting in chassis-based solutions. So drilling down a little bit more into the switches themselves in terms of the sort of the benefits of them and the features. So in terms of that performance, so throughput and power in terms of PoE. So firstly, you get what you pay for is exactly what it says. So we have non-blocking architectures. We don't share processing between ports like some of the cheaper switches from some vendors do, for example. So you get full line rate on every port. You're getting what you pay for in terms of if you're buying switch that supports multi-gig, you're getting that multi-gig across every port. We have options across all the switch families, going from the 1 gig right up to 100 gig connectivity. So whether you're using 25 gig for server connections or 10 gig for server connections, maybe using 40 gig for aggregation and 100 gig within your core. We've got options for all of those across our switch product families. The PoE, very, very scalable. So we've always had very good PoE budgets. So depending on the switch product family, you can do things like add additional PSUs for resilience and to provide additional power for PoE as well into the switches. So we've always had very, very good sort of class-leading PoE budgets in our switches. And very important, as we've talked about, for not just VAPs but other devices you may be able to, or maybe connecting. And we support all the standards and I should say non-standards as well, because some of those are standards based and some of those are sort of more vendor proprietary, but we support all of those as well. In terms of simplicity of deploying the ICX switches and scaling up and scaling across, as I said, going away from that sort of chassis base, but using stacking as a means of agile chassis, if you want. It's really very much a rack and stack solution. So you can have up to 12 switches stacked together. We don't use any proprietary stacking cables. We just use standard SFP plus ports. So you stack a 10 gig or potentially 40 gig or 100 gig, depending on the switch that you have and the uplink options. But that means that you don't have to have specific cables and you're not limited by the distance. So some vendors that have their proprietary stacking solutions, they may be limited in performance because it's an old stacking technology, and they're typically limited in distance as well. So if you wanted to, you could stack switches in different buildings on the same campus. You could stack switches across different campuses, across different physical locations if you've got fiber between them, for example, long reach fiber. So stacking is very, very flexible with the ICXs. And you also get things like, get a redundant stack manager. So one of the switches is allocated to be the stack management switch. It obviously does data forwarding and so on, but it looks overall after the stack. And a second switch will be allocated as being the redundant manager in there as well. And you can do things like in-service software updates as well. So so zero hits updates to software within the stack. So very, very, very powerful stacking for giving you agility in your network. The switches also have next business day replacement, so lifetime hardware warranty. So if you've had a switch for 5 years and the power supply blows up on it, you can log a support case and that switch will be replaced and you should get that next business day. And then in terms of management, as mentioned from the previous slide, it is about reducing management complexity. So the ability to actually be able to manage both the switches and the Wi-Fi network from the same controller. So whether that's our smart zone controller, whether it's our Ruckus Cloud public cloud offering, whether it's Unleashed for smaller networks, you can manage both the Wi-Fi and the wired network from that same console as well. So it makes it a lot simpler in terms of configuration, deployment, and troubleshooting. All the switches as well, they all use the same base or core OS. So it's based on the old Foundry, which is what Brocade acquired. So the core OS is the same effectively across all the switches. The CLI is the same. So the only thing you'll be missing or different is if you're on a low-end switch or entry-level switch like 7150 versus 7850, that may have some more features and functions which you wouldn't see on 7150 CLI, for example. But to all intents and purposes, the way you interact with switches is exactly the same. So whether it's an entry-level 7150 or a high-end core switch like the 7850, the way that you manage them is exactly the same. So it really makes it simple from that perspective in terms of management and upgrades and so on. And this is kind of what your network of the future will look like. So to support these new high-speed Wi-Fi 6 APs, to support your IoT, to support these faster devices, streaming 4K and in the future streaming 8K video perhaps. Your wireless edge is going to move potentially from 1 gig to multi-gig, 2.5, 5 gig, and potentially in places even 10 gig. And then your aggregation or direct connections to the core. Today, in some places, obviously, the limiting factor is the fiber. They still may be 1 gigabit per second. We have some solutions for that as well, using long range fiber solutions as well. So they can extend the distance, for example, of 10 gig networking, over a legacy fiber like OM1 and OM2, for example. But you may be constricted by legacy fiber, for example. But typically today with OM3 and OM4 fiber, going to go high speeds up here. There's going to be 10 or 40 gigabits per second potentially in terms of connecting the access layer to either the aggregation or the core layer. And then in the core, you may have servers connected at 10 or 25 gig, for example, and be doing stacking at 40 or 100 gig. And as I mentioned, of course, don't forget about your internet connections. So it's great having lots of power and performance and speed around here, but obviously you need to consider, if a lot of your business is about actually using the internet and internet-based applications, how much performance you actually need from that internet connection as well. In terms of the switch product family range, so this goes left to right in terms of performance, features, and price. So really the left-hand end here is all to do with access. Then in the middle, we have either premium access or aggregation. And then here we have sort of more core stroke backbone type of switching here, or switch product families. So on the left, very popular 7150 product range. So there's small desktop form factor switches. So there's 8-port, 10-port, 12-port switches, which also provide PoE on them. There are traditional rack-mounted 24 and 48-port switches. They can be PoE or non-PoE versions. There's also the ZP version, which provides 2.5 gig multi-gig ports on there as well. Also some additional redundancy in terms of fans and PSUs that you don't get on this base entry level model here. And as you move up, this is where you're starting to look at more sort of routing capabilities in terms of you are doing routing on switches somewhere. You get improved routing capabilities, you get improved performance. So you're starting to look at 10, 40, 100 gig connectivity options there. You're also looking at more multi-gig versions there as well. So 1, 2.5, 5 gig, 10 gig port availability on these switches, as well as fiber options as well. And you get more resilience in them. So as you go from left to right, these have the options for hot swap fans and power supply units as well. So as they go left to right, they get more powerful. So looking at that previous sort of network architecture, around here is your edge. Potentially here is your aggregation, and then here is your core, your backbone network here. All the way up to the premium 7850. And we've just released, for example, here a new one, so you can support fiber 10 and 25 gig, very high density connections, up to 128 connections per switch. And we've also released, for example, recently a 10 gig copper version as well, with 48 ports in it as well. So if you've got a lot of servers connecting the data center as sort of top of rack application, you can do that at 10 gig as well over copper. So a very good variety of switches. And as I say, the main thing, these can all be managed by cloud. They can be managed by the smart zone, all the same core OS on them, all the same CLI on them. Again, this is just a bit of a view of where those products will actually fit. So you've obviously got your different Wi-Fi access points here at the bottom, different flavors, and you see here multi-gig ports on them. Then you've got your access layer here. So depending on how much power, it may be 7150, maybe 7550 or 7650 either. A sort of aggregation layer here, where you're typically going to be aggregating more likely at sort of 40 gigabits per second, and then up to your core or your backbone network at the top, where depending on the scale of the network, it could be anything like a 7550. For larger networks, it'll be 7650 or maybe 7850 sitting at the top there of the network. So that's sort of typical network architecture. And then just to finish off, what Ruckus is trying to be to its customers is the fourth utility. Your customers expect to have fair electricity and expect it to be there and always on and reliable. They expect gas to be there if they're using gas services for heating or for restaurant use, whatever it may be. Expect there to be water as well, and this is what your customers expect from their network as well. They don't kind of really care. It's plumbing to them. When for the users of a network, and that's who it's about really, the users of a network, it's plumbing to them. They don't really care what's in there, but what they want is something that is that performs really well. It's got low latency. Their applications are very snappy. They can do data transfers really quickly, and that network is always up and reliable. It's always up and running. And that's really what we're trying to build with our solutions is really make a really solid, reliable, easy to manage solution for our customers, both for the IT team and for the users that actually use that network to do the customer's business. So at that point, I'm going to open up to any questions.
Real, thank you for that, Eddie. Quite insightful, to be fair. I got a quick question. On that last picture, when you're showing all the switches, you had them in pairs. Is that because you typically run them in pairs as a redundancy as part of the network design?
Yeah, I mean, generally you'd want to, but it's about capacity as well. So if you look at the access layer here, if you've only got 30 APs to connect in this location, you could put a 48 port switch in and just have a single one. But the diagram probably isn't, I mean, I've just taken a stock one from someone else's presentation. It's actually probably not the perfect illustration. You may, for example, have these connections, one connection to this stack of switches above in the aggregation layer, another one over to this side to provide you better resilience. So it's not necessarily the most accurate diagram in terms of how you do it. It may be a little bit more like this layer here shows you that you go to different switches here. You are going to different switches here from these connections, but they're going to be in the same stack effectively. So if there was something that brought the whole stack down, then you'd lose these switches as well. But if you'd more typically have one going here and one going here from a topology perspective for improved resilience. Good point there. Yeah. So yeah, typically these are kind of stacked for capacity, but typically yes, you'd always have certainly in the aggregation or core, you'd have at least two switches for resilience.
And another question then, the current range of the 7150s, are they powerful enough to run Wi-Fi 6E access points?
Yeah, so the ZP series it does have the multi-gig capability in it at 2.5 gig. So not really suitable if you want to be running the high end. So the first one that's coming out, the 860, because that actually has got 5 gig ports on it, so it wouldn't be suitable for that. So you'd need to go up to potentially 7550 range to provide 5 gig. Whilst it doesn't show it, it's got 1, 2.5, 5 gig ports within the range as well. So it does have the full multi-gig capability. So you may need to actually move up the product family slightly if you want to support the R860s, which will be the new high-end tri-band. When you're on the 660, I'm not sure whether that will have a 2.5 or a 5 gig port on it because it's 2 streams on each radio. So it may be okay with 2.5 gigs. So don't really have details on that yet.
Okay. I haven't got any other questions, but if there's anything you want to close off on, Eddie. Otherwise, if anyone does come up with questions post this, there will be a follow-up email, equally sending this as a pre-recorded webinar, so you can watch it again should you want to. And also, if any questions do come in, we'll be able to answer those and send them back. But failing than that, Eddie, I really appreciate your time. It's been really good.
No problem. Thank you for sitting and listening to this webinar, taking time out to do it. Hope you found it interesting.
Yep, I'm sure they did. I know I did. All right, have a good day.
Thank you.
Goodbye.
Bye.